Alrighty, now that you have watched the 2 intro videos to completing the square, we're now going to try it ourselves. And we're just going to start with some baby problems. We'll get into a little bit more intense problems on Monday. But for now, we're just going to focus on the baby ones. And I'll explain what that means a little bit later. So again, this is about completing the square. Even just the terminology completing the square probably means nothing to you right now, but it will here in a second. Before we go any further, I want to talk about what it is, like what it does for us. Basically, completing the square could have been the 5th tab in our Solving Quadratics book, okay? So if I gave you that equation, you could have found the x-intercepts by graphing, right? That was one of the methods we learned. You just put it in a calculator or Desmos or something, and you find the 2 solutions, the 2 roots, okay? That was one of the methods we learned. We also learned factoring, right? If you can take an equation or an expression and rewrite it in terms of its factors, something like this, and set them each equal to 0, you'd find the 2 solutions in that way as well. We also talked about square roots, which is similar to the video you watched a second ago. And we talked about the quadratic formula, the good old long crazy formula. Okay, those are the 2 we went over, or the 4, what am I saying? The 4 we went over. Basically, completing the square could have been the 5th, okay? And honestly, it's just a combination really of square roots and factoring. Combines the 2. Okay, so it does the exact same thing. It basically just finds the 2 roots of a quadratic equation. Okay, it is a little bit more complicated. Really not so bad once you practice it a few times. But you really have to have a solid understanding of square roots and factoring before you get there. Okay, so the problem I have up there, we're going to work with that one first. Because we're trying to find the x-intercepts, I'm going to go ahead and set this equal to 0. Remember that every x-intercept is going to have 0 as its y value, which is why we do that. It's always going to be a number and then 0. So this is equal to 0. Okay? Basically, completing the square means we want to rearrange and rewrite this equation so that we can complete it as a perfect square trinomial. Okay? So right now, x squared plus 6x minus 7 is not a perfect square trinomial. Could it be factored? Maybe we could work with that. But we want to figure out how to make it a perfect square trinomial and make this process a lot easier. Okay? 7 is not going to cut it. Okay? If I think about how a perfect square trinomial is formed, this middle term is the result of doubling something. Okay? So the result of doubling 3x. Well, square root of this is x, so that's what contributed the x. This isn't a perfect square at all, right? And it's supposed to be something that gives me a 3, so something's going wrong here. Okay? I'm going to go ahead and just erase all this for now. Let's just move the 7 over. We can't just erase it. We can't just get rid of it forever. Things don't work that way, unfortunately. So I'm going to go ahead and just add it to the other side. Yes, I intentionally left that little gap there. So x squared plus 6x something equals 7. I just moved the 7 over. What if, like we did in that other video, we figured out a number that we could add right there instead? So again, let's recap this. 3x is what would have been doubled to get the 6x. We know square root of this is x. Square root of this needs to be 3 to combine those 2 to make 3x, right? Well, what can I square root to get a 3? The only thing I can do is a 9, right? So cool, I'm going to put a 9 there. That's great, right? Except that it's an equation. So if I put a 9 on that side, I have to put a 9 over here. So x squared plus 6x plus 9 equals 7 plus 9. It's starting to look a little crazy, so let's simplify it a little bit and just rewrite it. My right side's actually 16. Okay? So now, this is much prettier. This right here is a perfect square trinomial. I can just rewrite it as the quantity of x plus 3 all squared instead, right? Okay, well that's great. So now, based off my square roots video, I know that x plus 3 is equal to the square root, right? Square root of 16, which is both 4 and negative 4. Okay, so now I just work backwards. Subtract 3, so x equals 1. Subtract 3, so x is negative 7. 2 answers, which makes sense because the whole point of this is to find the place it crosses the x-axis, and most quadratics, probably not all, definitely not all, cross in 2 places, 1, negative 7. Alrighty, I know that's a long process. I know there's a lot involved, so if you want to pause and rewatch that, feel free, but I do have 3 more examples coming your way. All right, so let's do this again. Again, I'm going to set this equal to 0 because I'm trying to find the x-intercepts. I'm going to add my 5 over because this is not a perfect square trinomial as it is right now. okay, you're going to find that you almost always do that. Add the c to the other side, okay? At this point, again, my goal is to make it a perfect square trinomial. I'm trying to complete the equation, complete the square, so that this can be easier, more easily factored. So this is the result of doubling 2x, right? How am I doing that? Basically, I'm taking half. I'm taking my b term and dividing it by 2, okay? Well, square root of this is x, so that's what contributed this x. Square root of this has to be a 2 for them together to make 2x, right? Well, what can I square root right here to make that 2? 4, right? Basically, we just square it. So I'm taking my b term, cutting it in half, and then squaring it. Well, if I'm going to add a 4 right here, I have to add a 4 over here. I have to keep the equation balanced. So let me rewrite to clean it up a little bit. 5 and 4 right here makes 9. Okay? So now, cool, this is a perfect square trinomial, which is just x minus 2 all squared. At this point, I can square root both sides. So x minus 2 can equal 3, or x minus 2 can equal negative 3. I add my 2 on both sides. So x equals 5, or x equals negative 1. 2 answers. Alrighty. This next problem is still considered a baby problem because it has a coefficient of 1 right here, and I'll talk about that in a second. But it is going to be a little bit weirder. We're going to start it out the same, though. Before I say it, think to yourself, what should my first step be? Good job. Add 24 to both sides. Okay, I want to go ahead and move my c value over. So x squared plus 8x plus we don't know is equal to 24. Okay, to find that we don't know, we cut this in half, so I get 4x. That means it's the combination of this x and this being a 4, right? Well, what can I square root to get to 4? 16. I just square it and go backwards. But if I'm going to add 16 right here, I have to add 16 over here. So x squared plus 8x plus 16 is equal to 40. Okay, so you can already tell kind of what's going to happen here. I'm going to rewrite this because it's a perfect square trinomial. And then I can go ahead and square root both sides. This is where some of you are saying, uh-oh, right? Is 40 a perfect square? No. So that means x plus 4 is equal to the square root of 40, or x plus 4 is equal to negative square root of 40, right? This is kind of yucky. If I subtract 4 from both sides, I can't really do that because it's a square root. So the other way of writing this would be for us to go ahead and just assume we're combining a negative 4 and a square root of 40 on both sides. So negative 4 plus or minus the square root of 40 would be our final answer here, which kind of looks like the quadratic formula, right? And we learned with the quadratic formula, if your discriminant is not a perfect square, you're going to have a weird looking answer, okay? And that's all right. It's not a big deal. That just means if you had done it on your calculator, your roots would have been decimals, and that's no big deal. Okay, so that's a weird problem. It's still a baby problem, but it's still weird, okay? Before I move on, I do want to talk about what makes it a baby problem. The formation of this number, right in blue up here, is a lot easier when a right here is a 1, right? When I halved this and got my 4x, it was very easy for me to know that I just take the 4 and square it to get the 16, right? But if this had been like a 4x squared, for example, that would have made the square root a 2x, which would have changed this over here to a 2. Everything would change at that point, right? So the baby problems, when I say baby, are the ones where this is a 1. The a value is a 1. On Monday, we'll tackle the ones where a is not 1. Alrighty? So I have one more example for you, and I really want this to be one where you kind of do it on your own, as far as you're going to pause the video and try it yourself before you move on. This is supposed to say minus 15. Sorry about that. So go ahead and jot that down. X squared plus 14x minus 15 equals 0. Y'all pause it here, and then try to do it on your own. Move your 15 over, complete the perfect square, work backwards to factor it, square root, don't forget your plus and minus, and see what you get. Pause now if you're still watching. Okay, sometimes I forget when I tell you how to pause that you can pause and I don't have to stop talking. So here we go. We are going to start by adding 15 to both sides. We want to move our c value over. So x squared plus 14x is a big old blank equals 15. Okay, I need to figure out what I can add in this location to make this a perfect square trinomial. Well, half of that is 7x. I pretty much am just going to square it, and I add 49 to both sides. Okay, just a little side note, this number right here, sometimes they write it like this, because you take the b value, this 14, you divide it in half, you get 7, and you square it to get the 49. Just so you know. Okay, let me rewrite. X squared plus 14x plus 49 equals 64. Okay, so then this is a perfect square trinomial. So x plus 7 all squared is 8. Oh, no, no, no. No, Miss McWilliams, not 8. I'm getting ahead of myself, sorry. Is 64. Now at this point, I can take my square root of both sides, which is where the 8 comes into play. So x plus 7 equals positive 8, and x plus 7 equals negative 8. I subtract 7 from both sides, and x is 1, and x is negative 15. Alrighty. So at this point, you can move on to the practice problems. Hopefully the sub will pass those out unless you already have them, in which case you can get going. There are more videos online. I know this is kind of a complicated topic. It's got a lot of steps to it, requires a really thorough understanding of factoring and square roots. So if you're still kind of shaky, there are lots of other videos out there. I've linked one for sure, but you could probably just Google completing the square, and there's tons of other videos out there that walk you through more examples. So feel free to do that if you're not understanding. Also feel free to talk with your friends, see if they can help explain anything. Sometimes it takes another student's voice to help things make sense. Please, please, please try to at least have an inkling of how this works before Monday. I don't want to have to reteach this entire lesson if at all possible. So just do the best you can. I appreciate y'all working hard while I'm gone, and I will see you Monday.